In this video, we will create a to-do list app in wxWidgets. So far in this series, I've shown you how to do a lot of different things in wxWidgets. In this episode, we will use what we've learned so far to create an actual application. Let me show you what it will look like. Here is the to-do list application. You can type in a task here, and if you click Add, then it is added to the list. As a shortcut, tasks can also be added by pressing the Enter key. When you have completed a task, you can check it like this. It's also possible to change the order of the tasks. To do that, just select one and then use the arrow keys to move it either up or down. When a task is selected, it can also be removed by pressing Delete on your keyboard. The tasks are saved to a text file, so if you close the program and open it up again, they are still there. If you want to remove all tasks from the list, you can click the Clear button. Then this dialog will appear, and if you click Yes, then the list becomes empty. Great. Let's build this application. Here I have an empty C++ project that I've already linked to wxWidgets. If you want to code along with me, then pause this video and follow my fast project setup guide. There should be a card on the screen now. First, I want to create a class that represents a task. In the header, we need to include string and vector. Next, I'll actually change the class to a struct. That will just make its members public by default. A task needs a string description. It could be buy groceries or do homework, for example. I'll also add a boolean called done. Done will be true if the task is completed and false otherwise. As mentioned earlier, we will save tasks to a text file so they can be loaded at startup. To accomplish that, let's add functions for saving and loading tasks. I'll call the save function save tasks to file. It takes two parameters, a vector of tasks and a string file name. Both are passed by const reference. The loading function should return a vector of tasks. I'll call it load tasks from file. It takes the file name as parameter. Instead of manually typing out the signatures again in the implementation file, we can use a little shortcut. If I put the blinker next to a function and then hit Ctrl dot, I can make Visual Studio create the definition for me. You can even write the implementation here, but I typically choose not to. So just hit Ctrl S and close this. I will use this shortcut for every function and method in this project. Okay, now let's open task.cpp. Here I will also include string and vector. This is not required because task.h already includes them. Nevertheless, it's good practice to add them here as well. That way you can easily tell which headers this file is using. We also need to include file system, fstream, and algorithm. Now we can implement save tasks to file. Its job is to store the given tasks in a file with the given file name. We start by creating an output file stream for the file. Then we write the number of tasks to the file. Next, we loop over all the tasks. For each of them, I'll grab the description. Instead of writing the description to file as it is, I'll first replace every empty space with an underscore. This step will just make loading tasks simpler because the description will always be read as one string, even if it contains spaces. Now we write the current task to the file. This line first writes a new line character, then our modified description, a space, and whether the task is done or not. Here is an example file. The first line states that it contains 3 tasks. The remaining lines contain a task description, followed by either 1 or 0. 1 means the task is done, and 0 means it is not. Note also that spaces are stored as underscores. Great. Let's implement load tasks from file. Its job is to parse a file like the one we just saw and turn it into a vector of task objects. When our final application is running for the first time, the task's text file will not have been created yet. So first, we need to check if the given file exists or not. As you can see, Visual Studio is not happy. That's because the exists function is only available in C++ 17 or later. To fix this error, go to the Solution Explorer, right-click on your project, and go to Properties. Make sure that Configuration is set to all configurations and Platform is set to all platforms. Then go to the General tab under Configuration Properties and set C++ language standard to C++ 17. Now Visual Studio shouldn't complain anymore. If the file does not exist, note the exclamation mark here, then we return an empty vector. Otherwise, if the file does exist, we create a vector for the tasks and an input file stream so we can read from the given file. Recall that the first line of the file contains the number of tasks. So we create an int n and read into it. Next, we add a loop with n iterations, one for each task in the file. Inside the loop, we need a description string and a done boolean. Then we read both from the file. Note that the description in the file contains no spaces, so it's very simple to read here because it will be treated as one string. We just have to remember to replace underscores with spaces now. Finally, we add the current task to the vector. And once all the tasks have been added, we return the final vector. We are now done with our task struct and the functions for saving and loading. Note that the code here is not coupled to wxWidgets at all. It doesn't even know that wxWidgets exists. That's a good thing, because it means we could use the same code with another GUI library, for example. But today we are using wxWidgets, so let's create a mainframe class. Here in the header, I'll include wx.h and make mainframe inherit from wxFrame. For now, I'll just add a constructor which takes a string title. In the implementation file, we have to include a few different header files. wx.h, vector, string, and task.h. Now let's implement the constructor. It has to call the base class's constructor. I'll pass in null pointer for the parent, give it some arbitrary ID, and for the title, we will use the title string. We'll come back here in a minute, but first we need an entry point for our application. So let's go ahead and create an app class. Here I'll also include wx.h. That way, we can make app inherit from wxApp. The app class must override a public method called onInit, which returns a boolean. let's go to the implementation file and write this method. First, we have to include mainframe.h. We create the mainframe inside onInit. I have creatively chosen to-do list for the title. Next, I'll set the frame's client size to 800 by 600. And let's make sure that it appears at the center of the screen. Now we just need to show it. And return true instead of false. Finally, we need to tell wxWidgets that our wxApp derived class is called app. We do this using the wxImplementApp macro. Now onInit should be called when we start our application. Alright, let's see what we've got so far. We have an empty frame with a title. For the rest of the video, we will only work in mainframe.cpp and mainframe.h. So let's close everything else and open up mainframe.h. In previous episodes, we usually just created our controls inside mainframe's constructor. But this time, we need to modify one control when the user interacts with another. So for easy access, we will make our controls private members. We need quite a few controls here. A wx panel, a wx static text control for the headline, a wx text control where the user can type in a task, a wx button for adding the current task, a wx checklist box for displaying the tasks, and finally another wx button for clearing all the tasks. To avoid cluttering, I'll also add a private method called createControls. As the name suggests, we will create the controls inside this method. Let's go to the implementation file and take care of that now. We start by creating a font for the headline text. It will be 36 pixels tall and bold. The 0 here just means choose a suitable width. We also need a font for all the other controls. This font is 24 pixels tall with the default normal font weight. Okay, let's add some controls. Like always, we start with a panel. Note that I did not write wx panel on the left hand side. Here we are referring to the panel that we declared in the header file. The pointer is stored inside the class. I'll set its font to main font. This will automatically apply the font to all the panel's children. Next, we can add the headline text. Its parent should be the panel. And I'll just give it some arbitrary ID. It will display the string to-do list. And I'll set its position to 0,22. For the size, I'll set width to 800 and height to the default -1. I'll also give it the style wx align center horizontal. And of course, headline text should use the headline font. This text will be horizontally centered near the top of the frame. To show you why, I'll temporarily set its background color to red. Now we can call create controls from the constructor. And start the application. Obviously, the red background color looks bad, but it makes it easy to see what's going on. The control spans the entire width of the frame, and the actual text is positioned in the middle. Next, I'll get rid of the background color. And add the remaining controls. This part is not super interesting, so I'll speed it up. If you are coding alongside with me, just pause the video and add these controls yourself. The program should now look like this. I don't know how easy it is to tell on YouTube, but the application is a little blurry. This may or may not be the case on your computer. It depends on your screen resolution and the amount of scaling your system applies. The blurriness is fixable, of course, but that's a story for another video. If your application looks blurry, you can go to your project properties and then under manifest tool and input output, you can set DPI awareness from none to high DPI aware. Now the application looks much more crisp, but the entire frame is also smaller than it was before. If it's too small on your screen, then go back and set DPI awareness to none. We will talk more about this issue and how to fix it properly in another episode. Alright. In the input field, I can type in a task, but nothing happens when I click the add button. So let's take care of that. In mainframe.h, we have to declare a few new methods. First of all, I'll add one called bind event handlers. As the name suggests, it's just a convenient place to bind our event handlers. Next, we need an event handler called onAddButtonClicked. we also need a little helper method called addTaskFromInput. Okay, back to the implementation file. Here we will bind our event handler so it gets called when the add button is clicked. Inside on add button clicked, I'll simply call addTaskFromInput. That method is responsible for creating a new task with the description currently written in the input field. First, we get the description by calling the input field's getValue method. If it is not empty, we insert it into the checklist box. The second parameter here is the index of the new item. I'm using checklist box getCount to make the new task appear at the bottom. You can use value 0 if you want it to appear at the top instead. Before we check if it works, we have to call bind event handlers from the constructor. Alright, let's try it out. It works, but note that the text in the input field is still there. It would be nice if it was cleared automatically. We can achieve that by calling clear in addTaskFromInput. I also want the input field to regain focus after we click add. So outside the if statement, I'll call setFocus on the input field. Now, when I add a new task, the input field is cleared, and I can start typing in a new one without having to click on the input field again. That's great. But it would also be convenient if I could just press enter on my keyboard instead of clicking add. To add this feature, we go to the header file and add another event handler. I'll call it onInputEnter. Back in the implementation file, we locate create controls and set input field style to wxTE_process_enter. Now we can bind onInputEnter to its text enter event. In onInputEnter, all we do is call our addTaskFromInput method. Now I can also add a task by just pressing enter on my keyboard. Great. Let's add the ability to delete tasks. In the header, I'll add a key event handler called onListKeyDown. Note that it takes a wx key event as parameter. We also need a little helper method called deleteSelectedTask. In bind event handlers, we call bind on the checklist box. The event tag we need is wxEVTKeyDown. And our event handler is onListKeyDown. Now, onListKeyDown will be called when the user presses a key while the checklist box has focus. Inside that method, we check which key was pressed. If it was the delete key, we call deleteSelectedTask. And break. Here we have to figure out which, if any, task was selected. We do that with the getSelection method. It returns the index of the selected item. If selected index is wx not found, it means that no item was selected. So we just return in this case. Otherwise, we delete the item at the selected index. Now I can select a task from the list and press delete to remove it. Great. Let's make it possible to rearrange tasks. In the header file, I'll add two more helper methods. The first one is called moveSelectedTask. The int parameter offset will either be -1 or +1, depending on whether the task should be moved up or down. To make moveSelectedTask easier to write, we also write a swapTasks method. Its job is to swap the tasks at index I and index j. Back in the implementation file, we must add two more cases in onListKeyDown. If the pressed key is the up arrow, then we call moveSelectedTask with a -1 offset. And break. If the down arrow was pressed, Then we call it with a +1 offset. How should move selected task look? First, we get the index of the selected task. If no item is selected, then we just return. Otherwise, we compute the new index for the selected task. If that index is valid, meaning that it's inside the list, we want to swap the tasks at selected index and new index. And to make this feel right, we need the item at new index to be selected after the swap. Now we just need to implement swap tasks. It won't swap the actual items in the list. It will just swap the text and check status of the items at indices I and j. Alright, first we create a task object for the item at index I. We get its description using checklist boxes getString method. It's complaining here because getString returns a wxString and we've used the standard string in the task struct. Thankfully, we can easily convert it using toStdString. To find out if the task is done, we call isChecked. Next, we create task j in the same way. Now we can update the contents of the checklist box. I'll set the string at index I to task j's description. And check it if task j is done. For index j in the list, it's the opposite. We set the string to task i's description. And check it if task I is done. Okay, let's check it out. Now I can select a task and move it up or down using the arrow keys. Note that the task I'm moving stays selected. But our clear button does nothing. So let's take care of that now. In the header file, I'll add another event handler called onClearButtonClicked. Obviously, it should be called when the user clicks clear. So let's hook that up in bind event handlers. Now we go to the event handler. Here we first check if the list is empty. If so, we do nothing and return. Otherwise, we should clear the checkbox, but only after the user confirms that they want to do so. For that, we create a wx message dialog. I will set its parent to be the mainframe itself. And then we have to provide a message and a caption. The message will be, "Are you sure you want to clear all tasks?" And the caption will be clear. We want the dialog to have a yes and a no button, so we use the wx yes no style. As well as wx cancel. Next, we call its showModal method and save the result it returns. If the user presses yes, then result will be wxID yes. So in this case, we clear the list. All right, let's try it out. If I click clear, this dialog shows up. You can see the caption here and the message here. If I click no, nothing happens. But if I click yes, then the list is cleared. Perfect. Our application is almost done. We just need to make tasks persistent so they are not forgotten when the program closes. In mainframe.h, I'll add an event handler called onWindowClosed. Note that it takes a wxClose event as parameter. As the name suggests, it should be called when the frame or window is closed. So let's go to bind event handlers. Here we call bind on the mainframe itself and use the wxEVT close window tag. In onWindowClosed, we want to turn every item in the checklist box into a task and then save the tasks in a text file. We start by creating a vector for the tasks. Next, we loop over every index in the checklist box. For each of them, we create a task, set its description to the string at index I in the checklist box, and set done to isChecked at index I. Finally, we add the new task to the vector. Outside the loop, we call the save tasks to file function we wrote in the beginning of this video. I'll pass in the tasks vector, and I want the file name to be tasks.txt. If that file doesn't exist, it will be created. If it does exist, it will be overwritten. We must also remember to call evt.skip, otherwise our application won't close. I notice now that save tasks to file starts with a lowercase letter, and I've used uppercase letters for all methods here. If you want to correct this, right-click here, go to rename, and then just change the lowercase s to an uppercase one. Then click preview and apply. This will change the name in the entire project. Okay, let's start the application and see if this works. I'll add a few generic tasks. And check the middle one. And then close the application. Now there should be a new file inside our project folder called tasks.txt. You can click this icon up here to show all files. Then you should see tasks.txt. If you don't see it, then try to click this refresh button. The last thing we need to do is load the tasks from this file when the application starts. So in the header file, I'll create a method called addSavedTasks. We call this method from the constructor. It's important that it's called after create controls. In addSavedTasks, we first call load tasks from file, which gives us a vector of tasks. Obviously, the file name here must be the same as in onWindowClosed, where we saved the tasks. Next, we loop over each task. Save the index where it should be placed in the list. And then insert it at that index. We also have to check it if the task is done. Finally, I'll just rename load tasks from file so it starts with an uppercase L. And that's it. Let's see if it works. Yep, our tasks have been successfully loaded from the file. The to-do list application works quite well, but it's not perfect. There is the blurriness issue that we saw earlier, and if I try to resize the application, then it doesn't behave as you might have hoped. I will show you how to improve this in the next few episodes of this series. Thank you for watching.